Alright, so chemistry, unit 9, lesson 9, lesson 10 will be very similar. For the last week of April, first week of May, we're getting close to the end, everyone. Your homeworks this week will be math, but will be short, so that's good news. Hopefully you can get both Wednesday and Friday all the work done, and video, homework, all that inclusive in about a half hour or less, so that would be good for everyone. Now, today we're going to talk about boiling point elevation, and on Friday we're going to talk about freezing point depression. Remember our concentration definitions, especially today, molality, not molarity, which we've been doing mostly, but molality, which is moles of solute divided by kilograms of solvent. I'm not going to do a whole lot of calculations with molality, but you need to know that that's what molality is. Molality is represented with a lowercase m, often italicized, where molarity is an uppercase m. So, boiling point elevation. The temperature difference between a pure solvent, boiling point, and the boiling point of a solution is called the boiling point elevation. Basically this. You have something like water. When you dissolve stuff in it, the boiling point goes up. And the more stuff you dissolve, the higher the boiling point gets. So the boiling point of water is 100 degrees Celsius. If you dissolve a bunch of salt in it, it goes up to as high as like 110, 105 degrees Celsius. All right, if you're boiling pasta, you can add salt to the water, and the water will get hotter, right? Because water doesn't go above 100 degrees before it turns into gas. But if you add salt, it can go to 101, 102 degrees before it turns into gas. So it'll cook it hotter, all right? And we can calculate exactly how much higher the boiling point will be with some very, very simple math. All right, and this is called calculating the boiling point elevation. All right, here's what it is. There's three things. The change in the boiling point, delta TB, change in temperature boiled, is equal to the constant of boiling times the molality. So every liquid has its own constant of boiling, its own Kb. Water has 0.512. That's its Kb. It's a constant. It doesn't change for anything. What you add to it doesn't matter. All that matters is the liquid. Some other liquids, benzene, carbon tetrachloride, ethanol, chloroform, just for reference, water has a really low Kb, all right, which means you got to add a lot of stuff to change the boiling point. Water's very rugged that way. So this is the formula. The change in the temperature, which is to say how much it increases, is Kb times molality. All right, so if your delta TB, your change in temperature was 5 degrees, your boiling point wouldn't be 5 degrees, it'd be 100 plus 5 degrees, because the normal boiling point's 100, so it'd be 105 degrees, and that's important to keep in mind. So I'm going to show you an example of this, and then you're going to do one, and then you're going to go back to playing Call of Duty or whatever you're doing. So, here's an example. What is the boiling point of a 0.029 molal aqueous solution of sodium chloride? Well, that means you have a solution of salt in water, and it's 0.029 molality. This would be a very normal amount of salt to add if you're cooking pasta, for example. So the real question is, how hot does your pasta water get? Well, let's look. The formula is delta TB equals Kb times molality. All right, well, we have the molality, just plug it in. So delta TB equals Kb times 0.029 molal. Well, we also have the Kb. Kb is a constant, it's the same, so water is 0.512. Now on your homework problem, you're going to have to know this, so I'd write this down. So delta TB equals 0.512 times 0.29. Well, great. That means it's 0.15 degrees Celsius. The change in boiling temperature is 0.015 degrees Celsius. But the question didn't ask what's the change in temperature. It says what's the boiling point. Well, you have to take your change and add it to your original boiling point. Water's easy. It boils at 100 degrees. So you take 100 degrees Celsius plus 0.015 degrees Celsius, and your final answer is 100.015 degrees Celsius. 100.015. So you plug in the numbers to get your delta TB, you add that to your original boiling point, and you're done. I'll show you where your homework is, and what it looks like. All right, so your homework is in your assignments. It'll be on current. Right now it's set to future because I set it up early, right? But you'll click Unit 9.9 homework, boiling point elevation. You'll have a multiple choice homework problem where you'll have to do what I did, follow the steps, you'll get it done no problem, and then you're done. So get that done by May 1st. That's Friday at 11:59 p.m. Although I recommend you do it before 11:59 p.m. because holy cow, don't stay up till midnight. You'll ruin your quarantine sleep schedule. So good luck with your homework. Stay safe and sane. I'll see you Friday.